A blade server is a stripped-down server computer with a modular design optimized to minimize the use of physical space and energy. Blade servers have many components removed to save space, minimize power consumption and other considerations, while still having all the functional components to be considered a computer. Unlike a rack-mount server, a blade server needs a blade enclosure, which can hold multiple blade servers, providing services such as power, cooling, networking, various interconnects and management. Together, blades and the blade enclosure form a blade system. Different blade providers have differing principles regarding what to include in the blade itself, and in the blade system as a whole. In a standard server rack configuration, one rack unit or 1U, 19 inches, 480 millimeters wide and 1.75 inches, 44 millimeters tall, defines the minimum possible size of any equipment. The principal benefit and justification of blade computing relates to lifting this restriction so as to reduce size requirements. The most common computer rack form factor is 42U high, which limits the number of discrete computer devices directly mountable in a rack to 42 components. Blades do not have this limitation. As of 2014, densities of up to 180 servers per blade system or 1440 servers per rack are achievable with blade systems. Enclosure or chassis performs many of the non-core computing services found in most computers. Non-blade systems typically use bulky, hot and space-inefficient components, and may duplicate these across many computers that may or may not perform at capacity. By locating these services in one place and sharing them among the blade computers, the overall utilization becomes higher. The specifics of which services are provided varies by vendor. Computers operate over a range of DC voltages, but utilities deliver power as AC, and at higher voltages than required within computers. Converting this current requires one or more power supply units, or SUS. To ensure that the failure of one power source does not affect the operation of the computer, even entry-level servers may have redundant power supplies, again adding to the bulk and heat output of the design. The blade enclosure's power supply provides a single power source for all blades within the enclosure. This single power source may come as a power supply in the enclosure or as a dedicated separate PSU supplying DC to multiple enclosures. This setup reduces the number of SUS required to provide a resilient power supply. The popularity of blade servers, and their own appetite for power, has led to an increase in the number of rack-mountable uninterruptible power supply or UPS units, including units targeted specifically towards blade servers, such as the BladUps. During operation, electrical and mechanical components produce heat, which a system must dissipate to ensure the proper functioning of its components. Most blade enclosures, like most computing systems, remove heat by using fans. A frequently underestimated problem when designing high-performance computer systems involves the conflict between the amount of heat a system generates and the ability of its fans to remove the heat. The blade's shared power and cooling means that it does not generate as much heat as traditional servers. Newer blade enclosures feature variable speed fans and control logic, or even liquid cooling systems that adjust to meet the system's cooling requirements. At the same time, the increased density of blade server configurations can still result in higher overall demands for cooling with racks populated at over 50% full. This is especially true with early generation blades. In absolute terms, a fully populated rack of blade servers is likely to require more cooling capacity than a fully populated rack of standard 1U servers. This is because one can fit up to 128 blade servers in the same rack that will only hold 42 1U rack mount servers. Blade servers generally include integrated or optional network interface controllers for Ethernet or host adapters for fiber channel storage systems or converged network adapter to combine storage and data via one fiber channel over Ethernet interface. In many blades at least one interface is embedded on the motherboard and extra interfaces can be added using mezzanine cards. A blade enclosure can provide individual external ports to which each network interface on the blade will connect. Alternatively, a blade enclosure can aggregate network interfaces into interconnect devices, such as switches, built into the blade enclosure or in networking blades. While computers typically use hard disks to store operating systems, applications and data, these are not necessarily required locally. Many storage connection methods, for example FireWire, SATA, eSATA, SCSI, SAS-DAS, FC and ISCSI, are readily moved outside the server, though not all are used in enterprise-level installations. Implementing these connection interfaces within the computer presents similar challenges to the networking interfaces. Indeed, ISCSI runs over the network interface, and similarly these can be removed from the blade and presented individually or aggregated either on the chassis or through other blades. The ability to boot the blade from a storage area network (SAN) allows for an entirely disk-free blade, an example of which implementation is the Intel Modular Server System. Since blade enclosures provide a standard method for delivering basic services to computer devices, other types of devices can also utilize blade enclosures. Blades providing switching, routing, storage, SAN and fiber channel access can slot into the enclosure to provide these services to all members of the enclosure. Systems administrators can use storage blades where a requirement exists for additional local storage. Blade servers function well for specific purposes such as web hosting, virtualization, and cluster computing. Individual blades are typically hot swappable. As users deal with larger and more diverse workloads, they add more processing power, memory and input-output bandwidth to blade servers. Although blade server technology in theory allows for open, cross-vendor solutions, the stage of development of the technology as of 2009 is such that users encounter fewer problems when using blades, racks and blade management tools from the same vendor. Eventual standardization of the technology might result in more choices for consumers. As of 2009, increasing numbers of third-party software vendors have started to enter this growing field. Blade servers do not, however, provide the answer to every computing problem. One can view them as a form of productized server farm that borrows from mainframe packaging, cooling, and power supply technology. Very large computing tasks may still require server farms of blade servers, and because of blade servers' high power density, can suffer even more acutely from the heating, ventilation, and air conditioning problems that affect large conventional server farms.